Hello everyone, welcome to Mechanics-V Logic. So currently we are solving the previous year question, CSIR-UGC question for the subject physics, and currently the topic is from the quantum mechanics. We have already solved three topics. So now the next topic is what we are solving is current topic. What we are solving is Schrödinger equation, and we have already solved three questions. Now let's move to the next question, which is fourth questions, and it has seven questions. So I will try to finish it as soon as possible. So let's move to the fourth question. So this question was asked in December 2016, and the question is: a particle in one dimension is in a potential Vx is equal to a delta x minus a. So this is a special Dirac delta function. So Dirac delta potential is here. Its wave function psi x is continuous everywhere. So the wave function is continuous everywhere. The discontinuity in d psi upon dx at x is equal to a. So what we have to find, where we have to find discontinuity? In its slope. So let's solve it. So from where we have to find, where we can find the discontinuity at x is equal to a. So to solve this, we will use Schrödinger equation. So let's write the Schrödinger equation for the potential, which is given here. So minus square by twice m d2 psi x upon dx square plus, what is Vx here? A delta x minus a psi x is equal to E psi x. Okay. So this is the typical Schrödinger equation. Now what we will do, we have to find the continuity dy upon dx. So from here we can get the dy upon dx. Now integrate this equation at x is equal to a. So let's integrate. For x a minus epsilon to a plus epsilon, a minus epsilon to a plus epsilon. Okay, so we can write here using, we can write using, so integration x is equal to a minus epsilon to a plus epsilon minus h cut square by twice m d2 psi upon dx square x plus a delta x minus a psi x dx is equal to E psi x integration a minus epsilon to a plus epsilon dx. So now just integrate it by part. First integrate the first part of the in the left side, and then we will integrate second part. Then we will go to the right hand side. So first part. So this will be minus h square by twice m. Okay, integration a minus epsilon to a plus epsilon d2 psi x upon dx square is equal to, with dx is equal to So this will be minus h cut square by twice m. So integration of d2 psi x upon dx square will give d psi x upon dx. Okay. So for we can write here a minus epsilon minus d psi x upon dx a plus epsilon. Okay. So this could be simplified minus h cut square by twice m. We can simply write psi dash a minus psi dash a plus. Okay. This is writing. This is a way to write this upon dx. Okay. So first part we have integrated here. So let's integrate second part. So second part here we have integration of a delta x minus a psi x dx. Okay. So this will be integration a minus epsilon to a plus epsilon a delta x minus a psi x dx. Okay. So here we use a property called sampling property. So what does it give us? It will as a epsilon tends to 0, a minus epsilon to a plus epsilon, it will give directly as a psi a. Okay, because at epsilon tends to 0, this part will become 1. Delta the x is equal to a, so this part will become 1. This will directly give us a psi a. Okay. Now let's solve the right hand side of the equation. So here RHS will give us minus a minus epsilon to a plus epsilon e psi x dx. So here what will happen? This will give us the value 0. So how it will give us? Simply as we integrate it, it will give dx will gives us the separation is as it tends to 0, it will give dx will tends to 2a. Okay, 2 epsilon. Sorry, this will be 2 epsilon. So it will give us like e psi a into twice epsilon, and as epsilon tends to 0, this whole part will become 0. This whole part will become 0. So this will give us directly 0. We can write here. So now writing all the three equation at a place, we will get minus h cut square by twice m psi dash a minus psi dash a minus psi dash a plus a psi a is equal to 0. Okay. So what will be the so what we have is psi dash a minus psi dash a plus is equal to, we can a psi a. Okay. So and this here this side will be h cut square by twice m. Now just take this part here, psi dash a minus psi dash a plus will give us twice m upon h cut square a psi a. So let's look at the option what we have. So here first a is the solution. Okay. So now we will solve the next question. So in the next video. So thank you. Let's meet in the next video.